And our very last section of chapter 6 here, it has to do with the study of the seas. We're going to be looking at a lot of things that oceanographers, a lot of technology that oceanographers would use, as well as a little bit of history of the study of the seas. It really began with the Portuguese and Spanish explorers during the Renaissance. After all, they were known for their sailing. A lot of the early explorers were either Portuguese or Spanish, the ones that were sailing around. Christopher Columbus sailed for the Queen Isabella of Spain, even though he was not Spanish himself. So the English weren't really into the exploring thing that early. They were still building up their navy. Once their navy was a force to be reckoned with, then we see the English coming onto the scene as far as studying the oceans and really exploring there. And one of the first research vessels was by the British. 1872, the British commissioned the HMS Challenger, and that was the first research vessel, period. A lot of the other vessels were exploratory. They were designed to go places, but they weren't really designed to research. The HMS Challenger is one of the first on record as being designed for research, or at least having a crew with the capability of research. Had a 4-year voyage around the world to map the sea floor. That was its primary goal. And it had a team of researchers on there, as well as the ship's complement of crew to keep it running. And these researchers collected so much information, it took 30 years and 50 volumes to publish it all. And it was only a crew of around 6 people, if I remember right. But after going around the world and collecting the samples they did for only 4 years, really, which isn't that long of a time frame, but it took them 30 years and 50 separate books to publish all of the information. Now, one of the primary tools of the oceanographer is the research vessel, possibly the most important tool. It is equipped with scientific instruments, laboratories, libraries, and a scientific team dedicated to the research. Provides a working platform and a mobile research laboratory, usually having all the equipment they need to do all the different studies, to do all the different experiments while they're out at sea. Now, a few different research vessels. I have 3 on this slide. We have the Woods Hole Oceanographic Institute, their research vessel, the Nor, in the upper left here. And you can look at the back and see lots of different equipment that you don't normally see on a lot of ships. We have the Maria S. Marianne out of Germany. You can see some cranes, a launch there on the back side, as well as different places to store things and equipment. We have the French Marion Dufresne, I believe is how it's pronounced. You can even see a little helipad on the back of that one for helicopter, as well as cranes. There's labs in there. You can see some of the portholes and stuff. But they have equipment, labs, and whatnot for the design. And they can switch out some of that equipment if they're needing specialized equipment, or if they're going to go on a long voyage with a very specific study in mind. They can swap out some of that equipment if they need to. Kind of a unique one here is the U.S. Navy's FLIP, the Floating Instrument Platform. In the upper left, you can see it's actually towed out. It doesn't have its own engines. It's towed out to its location, and then it actually sucks water into tanks at the end, causing the whole thing to flip upright. And in the bottom picture there, you can see the flip as it's stationed there. Several anchors probably off into the ocean there. It's actually fairly steady, I've read. With that big end there filled with water, it doesn't bob very much, and it actually provides a very steady platform to work from out in the middle of the ocean. You can see cranes and other equipment on the decks there. Another good tool, another useful tool is the submersible. It's mainly small research submarines. We're not talking about like Navy submarines here. These allow oceanographers to visit deeper portions of the ocean, taking samples, or just seeing things. It's amazing what we've learned from just being able to see deeper in the ocean with a submersible. One of the earliest ones was called the Bathyscaphe, invented by Auguste Piccard. It was a breakthrough in submersible design because it actually allowed them to go down fairly deep. First one was constructed in 1948 And yeah, this is just I believe this is just a diagram of a generic bathyscaphe design. You have this it's almost kind of like a blimp. You have this giant container above it that is used for submerging and surfacing, and then really the part where the person is sitting is right underneath. You have this observation bubble almost underneath. Everything else above it is designed for getting it up and down. This was one of the earliest designs. It's actually a design that is still used for some types of submersibles today. Here are some other deep sea vehicles, deep submergence vehicles. These are modern manned submarines. We have the, again, Woods Hole Oceanographic Institute running the Alvin here on the far left. You can see a gentleman on top giving you an idea of scale. We have Mir 1 on the right here. This is run by the Russian Academy of Sciences. Again, you have a couple guys in a raft there giving you an idea of scale. We have the Clelia, at least I think that's how it's pronounced, which is designed for moving along the bottom of the ocean, getting samples there. And then we have the Deep Worker, which is just it's a one-man submersible. Almost looks like a little bit of a race car to me. It's got the submersible, the dome there for the oceanographer to study from, to observe from. It's got several lights on the front. I don't see any arms on this one. I mean, it could have some devices there to get samples, but they're just not obvious in that picture. Then there's also remotely operated vehicles, or ROVs. These are highly maneuverable robots linked to support ships by cables. One is the Jason Jr. there. That's actually a picture of Jason Jr. On the far left as it's exploring the Titanic. This picture is actually the one that popped up the most when I just looked up ROVs. And then you have the Argo as well. And that's another one there, a little bit longer of a ship, or of a ROV. You have the Abe, which is actually an acronym for Autonomous Benthic Explorer. Not sure what Benthic means, didn't look it up. But that's what the acronym Abe actually stands for. It's an ROV. We have the Tiburon at the bottom left here. A little bit more going on with the Tiburon. Looks like a little bit larger one compared to, especially to like Jason Jr. or Abe. And then we also have the, I believe it's pronounced Keiko. Not entirely 100% on that, but I believe that's how it's pronounced. Another ROV submersible. Then we also have Undersea Labs. The U.S. Navy had Sea Lab 2 going for several years. It's no longer in use. And that for its divers, learning stuff about the ocean floor. We also have Conshelf 1 here. I believe that was actually a French attempt. Well, not attempt. It was successful. The French plan as far as their underwater sea lab area, where there's laboratories and research capabilities there. These are not necessarily deep sea. As you can see by the Aquarius one here in the bottom left-hand corner, we're actually still getting light in the water. So they are underwater several hundred feet at least, but we're not talking about the bottom of the ocean here. We're probably talking about on the continental margin somewhere, possibly even the continental shelf. And the Aquarius is actually the only one that's actually still being used today. It's off the coast of Florida. NASA actually uses it occasionally to prepare astronauts, or at least it used to, since we don't really have astronauts going into space right now. They're probably not using it so much. Other equipment of the oceanographer. Buoys, floating observation stations that automatically take measurements, transmitting the data to oceanographers. After all, there's some data that, as an oceanographer, it would just be time-consuming and tedious to go out and take these measurements. Air temperature, water temperature, salinity levels, other things like that, where you can actually program a computer and it can read all of that. It has sensors on it, reads all that, and just transmit it back to the oceanographer. This allows for accurate and long-term studies as the data is collected. An early, well, it wasn't an early version of a buoy, but an early tool was the drift bottle. It was a weighted bottle set adrift in the ocean, contained an address to be contacted when the bottle is found. I believe it was Admiral Matthew Perry, one of the early oceanographers, used this to study currents. Current speed and direction could then be calculated based upon, because the oceanographer knew when he threw the bottle in the ocean, And then he could calculate how long it took to get to a certain area because people would say, we found it on this day. And he could get a pretty rough estimate there, a pretty good one. Not 100% accurate, but pretty close. The modern day version of that is something called profiling floats. Profiling floats. These go underwater a little bit further. They don't ride near the surface. They'll go a little bit deeper. They can take other measurements other than just speed and direction. And every 7 or 10 days, depending on what the researcher wants to know, how often they want to know, it will surface, transmit the data via satellite to the researcher, and he can just take the data. This eliminates the need to rely on other people. So if it ends up in an area where there's no people and you just lose track of it, you still get data this way. With the drift bottles, if there was nobody on the other end, you didn't get the data. You couldn't figure it out. Niskin bottles are a way of taking water samples, and you can take several samples at a time depending on how your setup is. But these are plastic tubes on a weighted line that is lowered into the ocean. The tubes collect water samples, and you can then take measurements from various depths, actually. And on this page, we have a few pictures. Some of them are actually the same picture that out of our book. In the top left here, we have an oceanographic buoy, not to be confused with directional buoys that are markers for ships. These collect a lot of data. You can see instruments at the top to collect wind speed, wind temperature, and there's probably an antenna in there as well to transmit that data. You see a drift bottle in the middle there, just a bottle with a note in it and a stopper to keep it floating. The profiling float on the right here, this is actually the same picture out of our book. There's a satellite antenna at the top so that when it rises, it can transmit that data, battery, gears, and everything else that's needed to make it move, as well as, and it has a temperature and salinity probe at the top there to take measurements with. At the bottom here, we have Niskin bottles, plural. Each one of those gray things is a Niskin bottle. What we have here is what's called a rosette. This is a framework to which many Niskin bottles are attached, so that they can take several samples. They can probably even program it as it's lowering. One bottle opens up, takes a sample, closes. 100 feet later, another bottle opens up, takes a sample, closes. 100 feet later, the third bottle opens up, and just until all of them are filled, and they get samples from several different depths to compare it from one area. Another device that is used if they want to take sediment samples, but they don't have access to a submersible with the ability, they could use a gravity core. And this is actually a picture of one on a small boat. I believe this boat is actually out in the middle of the lake, not in an ocean. But it's a device with an open tube that is dropped to the sea floor. Gravity pulls it downward, allowing its weight to puncture the sediment. And then when it's pulled back up, you have a sample of the sediment. There's actually another type of core, and that's a piston core, capable of extracting cores up to 90 feet long, so a much larger sample. This causes less sediment disturbance, so when it hits, it doesn't cause a lot of sediments to float around, so you get a more accurate reading. Don't forget, or I hope you don't miss at the bottom here, we have number 7. A core is a narrow column of sediment. I forgot the word is, I apologize for that. But a core is a narrow column of sediment, and you can see the different levels in it, what kind of sediment it is, 10 feet under the ground, 20 feet, 30 feet, especially if we're using a piston core here, if there is any difference. Some other devices to use for measuring. Sonar is used to measure size, shape of an underwater object, as well as the distance to an underwater object. Many fishermen use a type of sonar to see if fish are swimming around underneath their boats. What sonar stands for is sound, navigation, and ranging. The SO from sound, the NA from navigation, and the R from ranging combined to make the word sonar. This was actually developed during World War II to fight U-boats, the first modern submarines, we'll say it that way. And then later on it was realized, hey, we can actually use this to find other things. Sonar was a major resource in locating the debris of the Titanic. Without sonar, it would have been taken much longer and been a much more tedious job of finding anything. One of the last things here, but probably one of the most important out of the general equipment, is the scuba. It was invented in 1943 by Jacques-Yves Cousteau and Emile Gagnon. SCUBA stands for Self-Contained Underwater Breathing Apparatus. Consists of a high-pressure air cylinder, the yellow tank, strapped to the back. A hose connects the cylinder to the diver's mouthpiece, and then a regulator controls the airflow. After all, you don't want to be breathing in a fan, because that's under a lot of pressure, and that could, if it was left unregulated, that could actually cause problems. So yeah, this allowed divers to stay underwater much longer. Was probably, along with the bathyscaphe or the submersible, those two together probably really revolutionized oceanography. A lot of the other stuff that we've talked about came around later than either of those two. And I know Jacques-Yves Cousteau was a very famous, very important person as far as our understanding of the oceans went. So that is actually the end of 6.4, the end of the chapter. We'll be doing some reviews soon. Also, for our science video question, it is going to be related to the, let's see, which one was it? It was related to the boys, is what our science video question is going to be related to. Is going to be related to those boys. So make sure you got that information so you can answer that question. Remember, with Classcraft, if you answer that question correctly, I might add, you'll get gold and experience at this point in time. So that's where we will end this chapter at.